On October 19, 2017, a rather peculiar interstellar asteroid was observed for the first time in human history. Picked up by the Panoramic Survey Telescope and Rapid Response System, the object was initially suspected to be a fast-moving asteroid within our solar system yet to be discovered. If you're not familiar with Pan-STARRS, its mission is primarily to detect near-Earth objects that could pose a threat to our existence. After discovering the object and calculating the trajectory, it became apparent this object was in fact alien to our solar system. Originally classified as an interstellar comet, astronomers have since reclassified it as an interstellar asteroid with the designation 1I 2017 U1 Oumuamua. This reclassification came after no coma was observed during its closest pass by the Sun, indicating the object was in fact more like an asteroid. The I signifies an interstellar asteroid, with 1 being the first discovered. Its name is from the Hawaiian language and is loosely translated as Scout, meant to symbolize the first scout to visit Earth from interstellar space. Passing through our solar system on a hyperbolic trajectory, its eccentricity was calculated at 1.2. Anything over 1 indicates enough velocity that even the Sun's immense gravity can't capture it. Its trajectory brought it over the top of our Sun before heading past the Earth. Its speed has been calculated at 26 kilometers per second. That's about 59,000 miles per hour, or over 3 times faster than the velocity ISS orbits Earth. We can't say for certain where this asteroid originated, but its trajectory brought it from the general direction of Vega, the brightest star in the northern constellation of Lyra. Recall the movie Contact, in which humans received the first communication from an intelligent species coming from Vega? A coincidence to be sure, for it's more likely this object did not originate there, not to mention the fact it's simply a rock drifting through space. But nevertheless, it's sometimes spooky how science fiction almost seems to predict reality. Further observations by the European Southern Observatory in Chile shows this asteroid from interstellar space looks nothing like what we've come to expect an asteroid to look like. Although it appears as a tiny pixel through our most powerful telescopes, we've been able to ascertain some of its characteristics. Our first visitor from deep space is about 400 meters or 1,300 feet in length. If you stood this thing upright, it would nearly match the height of the Empire State Building in New York City. It has a highly elongated shape, being about 10 times longer than it is wide. How it got this peculiar shape is quite puzzling for astronomers. Every asteroid we've seen in our solar system has the appearance of a rough rock or boulder-shaped object, too small for gravity to compress them into a sphere as planets and large moons are shaped, but they at least try to obtain a spherical shape, with none of them having such a large ratio between length and width. Our first observation of an interstellar object that happens to be shaped like a spaceship is both intriguing and eerie. It was also discovered this asteroid spins on its axis every 7.3 hours. Astronomers believe its composition is dense with rock and a high metal content, lacking any significant amount of water ice. Spectroscopy observations show the object has a dark and red color, which is likely from trace amounts of tholins. These are organic molecules that can yield the reddish appearance due to the effects of irradiation from cosmic rays over millions of years. There's no doubt the significance of this incredible discovery, but unfortunately we couldn't see it coming in advance, so launching a spacecraft to intercept it was never feasible. However, a team from Project Lyra have proposed chasing down this alien rock. The real problem, of course, is the velocity required for such a flight. The fastest spacecraft humans have ever built in terms of launch velocity is the New Horizons probe, which launched to Pluto in 2006. Departing Earth at 58,000 kilometers per second, or 38,000 miles per hour, the launch velocity achieved by New Horizons is still short by 21,000 miles per hour. And that would only match the speed of our desired target. Remember that we must chase it down because every day it moves further and further away from Earth. Without utilizing gravity assist, there is simply no way our current chemical rocket technology would be able to chase down an object moving at such a high velocity. Given our current technology, it would most likely involve a slingshot by Jupiter to establish a close pass by the Sun. This type of maneuver would dramatically reduce the amount of fuel required to reach the chase velocity needed. What's known as the Oberth effect allows for such a maneuver. This explains that the most efficient way to gain kinetic energy is to accelerate when the spacecraft is traveling fastest as it falls within a gravitational well. In this case, the spacecraft would be traveling faster at its closest pass by the Sun. The closer you can pass, the less delta velocity required to achieve the speed for an encounter with the asteroid. But of course, passing closely to the Sun presents its own problems, such as cooking the spacecraft from the intense heat experienced that close to the Sun. It's obvious that any such mission to chase down this object needs to launch sooner than later, but using gravity assist to get there involves waiting for planets to align, which moves any potential encounter even further away from Earth. The team at Project Lyra acknowledges the challenges, but they assert that such a mission offers great opportunities to expand our research and development of new technologies that could allow for alternative propulsion through space. It seems unlikely that we'll ever launch a mission to study the first interstellar asteroid discovered by humans, but hopefully it will inspire us to advance our spaceflight technology. Space will always remain the final frontier, and I believe it's very important we constantly enhance our knowledge about it. Until next time, my friends, happy orbiting.